Hey there, welcome to this video. This is 8-5 and we are talking trigonometry. This is going to be a review video on trigonometry, and we're going to talk about lots of stuff that you would have talked about in previous classes and utilized prior to coming into calculus. So let's go ahead and dust off those cobwebs on trigonometry. So basic foundational right triangle trigonometry. If we have a right triangle and we place an angle theta, say in this corner, right, in this angle, okay, or the other one, we can come up with sides, right? So if this is theta, this is the side opposite, this is the side adjacent, and the hypotenuse is always across from our right angle. Then we can come up with these trigonometric functions: sine, cosine, tangent, and how they're derived, right, is the ratio of the lengths of the sides. So sine theta is equal to the ratio of the side opposite divided by the hypotenuse. Cosine, adjacent over hypotenuse, tangent, opposite over adjacent, right? You guys remember that? So cosecant, secant, and cotangent, these are the reciprocals of our previous functions. So cosecant theta, that's just the reciprocal of sine. Secant theta, reciprocal of cosine. And last but not least, cotangent is the reciprocal of tangent. Okay, so let's go ahead and look at a basic example. Here we have a right triangle, and theta is placed in this corner. So that's very, very important to know, okay, like what angle are we talking about? They want sine of theta. Okay, well, sine of theta, that is opposite over hypotenuse. So 4/5. Very easy, right? Cosine of theta, well, that's the side adjacent over hypotenuse. So 3/5. And sometimes people get confused, like which side's adjacent, which side's opposite, which one's hypotenuse. Well, again, remember, hypotenuse is always across, right, from our right angle, and the side opposite is directly opposite the angle. So that's how I kind of go ahead and label. Here's theta, so right, so this is opposite, right, this is adjacent, it's next to it, and it's not the hypotenuse. Here's the hypotenuse. Tan theta, that is opposite over adjacent. Okay, so 4/3. And secant theta, well, secant theta is equal to the reciprocal of cosine theta. Okay, and that is just 5/3. All right, so very, very foundational things. All right, let's go ahead and talk about trig functions defined as circular functions. And I just want to cover some foundational vocabulary with you. Remember that if an angle is in standard position, okay, the initial side is the side along the positive x-axis, all right, and the terminal side, which I'll put in red, terminal, red, that is the side where the angle ends, right? So this is theta, and here, right, here's theta, and this is a positive angle. If I was going negative, right, it would go the opposite direction, or it would go clockwise, okay? So we use these to go ahead and develop circular function trig definitions, okay? And you can see these here below, right? So sine of theta is y/r, right? So if this is my angle, okay, I can go ahead and have a coterminal angle, which is here, right? And these are equivalent. So for instance, if this is theta, my sine function would be y/r. Okay, and that's just the main idea here, right? This is an angle that's in standard position, and then we also have coterminal angles, right? Angles that end in the same location, and they'll have the same exact values. Okay, so coterminal angles. There's an example. All right, so we're going to go ahead and we're going to work with these. We're going to calculate some values using this idea, and just another kind of note here that if theta is any measure, the radius is equal to the square root of x squared plus y squared, and that's derived from the Pythagorean theorem. So you'll see me use that shortcut here in a second. All right, example 2, they say find sine theta, cosecant theta, and cotangent theta if theta is in an angle in standard position whose terminal side passes through the point 5, -2. So I'm going to go ahead and I'm going to draw a picture. Beautiful. And go ahead and put some coordinate grids here. Okay, and they want the point -5, 2. And that's right here. Okay, so as a triangle, it would look something like this, right? Here is theta, right? An angle that passes through that. Well, it's important to note that we also have a coterminal angle here. So here's its coterminal angle, right? Which makes a right triangle. Whoa, there it is, right? And this is the triangle that we're going to go ahead and use. Okay, so we want to place in distances. This distance is -5. This distance is 2. And we want to go ahead and calculate these values. Well, for sine of theta, what we're going to need is we're going to need our radius over here, okay? And so that is, again, the square root of these two values squared. So 4 plus 25, that is 29, right? 2 squared plus 5 squared, okay? So root 29. Okay, so let's go ahead and find these values. So what's sine of theta? Well, opposite. Okay, that's 2 over hypotenuse, root 29. Hey, that's easy. Okay, cosecant theta. Well, cosecant, that is the reciprocal of sine. So isn't that root 29 over 2? Okay, and cotangent theta. Cotangent theta is the reciprocal of tangent, opposite over hypotenuse. So that one is going to be -5/2. Okay, and you can go ahead, you can reduce that if you want, but that's fine. Now, I know some of you are freaking out. You're like, hey, you have a radical in the denominator here. So what, can't you calculate that in a calculator? 2 divided by square root of 29? Yes, I know some mathematicians, especially traditional mathematicians, they like you to rationalize that. Okay, if your professor or your teacher wants you to do that. For sakes of calculus and calculating values, you have a calculator that can do that. You're done. You're welcome. All right, circular function trigonometry makes use of reference angles. And that's what I was just talking about. Okay, and these special triangles here, right, which are very, very special triangles. Special triangles. You would be highly advised to go ahead and memorize these. And here are that's the bell. Here are the special triangles below. We have a 30, 60, 90 triangle, right? 30, 60 degrees, 90. And then same triangle here, 30, 60, 90. And then we also have 45, 45, 90. Okay, now these special triangles always have the same side length, right, and ratio of these sides. So if I am a 30, 60, 90 triangle, okay, the side lengths are going to be 1, right, and that corresponds to 30. It's the smallest angle, so it gets the smallest side. Then we have 60, that's root 3, and then 90 is 2. Okay, so 30, 60, 90s have 1, 2, and 3, with the square root of 3 being in the middle. Okay, so 90 gets the biggest side, that's 2. We also have 45, 45, 90, and 45, 45, right, if this is 45 degrees, well, that makes a isosceles triangle. These two sides are the same, so 1, 1, root 2, and these are the special triangles that we'll use. All right, and I want to go ahead and remind you that these special right triangles, the sides are all derived from the Pythagorean theorem. So if you're kind of confused, where are you getting like these values? This relationship, this ratio holds true always, and sometimes you'll see triangles change, right? But the ratio holds, and if you ever want to find one, you can utilize Pythagorean theorem. Okay. Now, I want to go ahead and I want to do example 3 before I cut this video off and then move into another video. But we're asked to draw angles in standard positions and make reference triangles. So cosine of 210, so if I draw an x and a y-axis, and I'll draw my angle. So here's my initial side, 210 degrees. Well, here's 180 and about 30 degrees in more here. Okay, so there is 210 degrees. And if we want to make a reference angle, right, our reference triangle, okay, that is going to be here. So here's our reference triangle, right? And I'm going to go ahead and zoom in. And this would be 30 degrees, right? 30 degrees. This would be 60 degrees. Okay, here's our right angle. And I need to go ahead and place the values. Well, again, remember 30, 60, 90. 30, 60, 90. Okay, the side lengths are 1, root 3, 2. So hypotenuse is the biggest. Okay, that's 2. Across from the 30 is the smallest. That's 1. And root 3 is in this side. Now, it's also important to note this is in the third quadrant. So our root 3 is negative, as well as our 1 is negative. Okay, and there's your reference triangle. All right, we'll go ahead and do the same thing now for B. Okay, and I'm going to go ahead. There's initial side. I'll go ahead and go around, and that's about 315 degrees. Okay, there's 315 degrees. And the reference angle that is made, again, they have to be less than 90. So here's our reference angle, our reference triangle. Okay, and what's left over is 45 degrees. So we get a 45, 45, 90. It's kind of, I want to draw it better. So, okay, so 45, 45, and here's our 90-degree angle. Okay, and the sides across from the 45 are 1, right? So 1, and the side across from the hypotenuse is root 2. Okay, so again, those are the special triangles, right? So and I'll write this here. So 45, 45, 90 is 1, 1, root 2. All right, I'm going to go ahead. I'm going to pause the video since this is getting kind of long and split up the second one. All right, basic trigonometry. Next, we're going to go ahead and move into radians, everyone's favorite degree of measurement. Catch you next time. Peace.